Yes, student. Next content is ionization enthalpy. Ionization enthalpy of p block elements are lies between S and p block elements. Okay, why? Student, as we know, on moving from left to right, number of proton increases gradually by 1. Therefore, nuclear attraction force gradually increases, atomic size decreases, and therefore the ionization enthalpy regularly increases. Now, the T block elements are placed just between S block and P block. Therefore, their ionization enthalpies are what? Higher as compared to S block element, but lower as compared to P block elements. Therefore, we are saying their ionization enthalpies are lies between S and P block elements. Okay, but lot of irregularities are also observed. Lot of irregularities are also there. Okay, now which are these irregularities? Like here, first one. Okay, ionization enthalpy. Which one? First. Okay, of chromium is lesser. Ionization enthalpy of chromium is lesser. Now, what is the reason behind it? What is the reason behind it? Now, but we will compare what? As compared to Mn. So, first we have to write the configuration. What is the configuration? This is what? 3d5 and 4s1. But in the case of Mn, the configuration is 3d5 4s2. Obviously, you can check here. The last electron is in S subshell and unpaired, while in case of Mn, the last electron is in S subshell and is paired. Therefore, its ionization enthalpy is higher as compared to what? Chromium. Isn't it? Actually, student, what happens? After removal of electron, now the 3d5, it becomes completely half-filled, which shows the extra stability. But here, after removal of electron, again the configuration of Mn remains what? 4s1, that is unstable. That means what? Second ionization enthalpy, okay, of Cr is quite higher as compared to Mn. As compared to what? Mn. Now, why it will become higher as compared to Mn? It is because it will acquire what? Noble gas electronic configuration. Isn't it? Similarly, we will observe some very different term, like here, number 2, ionization enthalpy of Zn is very high in 3D series. Very high. Now, why? Because its configuration is 3d10 and 4s2. This is called what? Fully filled electronic configuration. Therefore, its ionization enthalpy becomes very high. Similarly, if we see second ionization enthalpy of Zn will become lower. Becomes what? Lower. Now why? After removal of electron, again it will acquire what? Unstable configuration. So it will become high. But what about the third ionization enthalpy? Third ionization enthalpy of Zn will become very high. Will become very high. And therefore Zn is unable to form Zn plus 3. Generally you will see that the most stable configuration of Zn is what? Oxidation state is plus 2. Actually what, student? After removal of electron, there is energy exchange takes place between S and D subshell. S and D subshell. That is what? After removal of S electron, sometime the D becomes fully filled or sometime it becomes half filled, like in the case of chromium, in the case of copper. And thus the exchange energy accompanying with the ionization energy, and the difference of this energy is getting releases, and thus sometime the species acquire noble gas electronic configuration. So this type of trend you will observe in the case of ionization enthalpy. Large anomalies are there, like here you can see some more anomaly. Third ionization enthalpy of iron. Okay, what is the meaning of third ionization enthalpy? That is, you can say, that is change of Fe plus 2 to Fe plus 3. Now what about the configuration of Fe plus 2? The configuration of Fe plus 2 is what? 3D, okay, and 6 and 4s0. This is the configuration of 3D, Fe plus 2. But when it will become, that is, it has to become Fe plus 3. Fe plus 3. Now the configuration is become what? 3D5 and 4s0. Isn't it? Actually 4s2 and 3d6. This is the configuration of pure iron. But after removal of 2 electrons, the 4s will not have any electron. So what about ionization enthalpy? The second ionization enthalpy of iron will become lower. Isn't it? That is, to convert from Fe plus 2 to Fe plus 3, it has what? Lower ionization enthalpy. And